Welcome to the last section of the chapter, 4.6 Arithmetic Sequences. This is page 116 of your student journal. I think this is going to be the easiest section of this chapter. I hope it is. So let's see. How can you use an arithmetic sequence to describe a pattern? We're actually going to go into the explorers this time. And we take a look at this number of stars. Well, here there is one star. How many sides are there? There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. So if one star has 10 sides, how many sides does two stars have? 20. I'm actually going to make this a little thinner. 30. That's better. 40 and 50. And then graph it. 1, 10, 2, 20, 3, 30, 4, 40, 5, 50. Right? It's pretty simple. Number of circles. Let's see here. Oh, sorry. The directions say, describe the pattern of the y values. Okay, that was actually really important. So we had 10, 20. What's happening to it every time? Is it going up or down? And if it is going up, how much is it going up by or down by? Well, 10 to 20 is an increase. It's going up by 10. And it actually does that consistently. So the pattern of y values that is increasing by 10. Here we have two circles. 1, 2, 1, 2, 3, 1, 2, 3, 4. So you have 2, 3, 4, 5, and 6 if you count them carefully. And the graph will look like this. I should leave that there. 1, 2, 2, 3, and so on and so forth. Describing the pattern of y values. What's happening to it? It's increasing by 1. I'm having a hard time moving this now. What the heck? Alright, well, let's move it to the side. At least. Oh, okay. So now, I'm actually just going to skip this one because you kind of get the point already. We're even going to skip the definitions. We just go over them like this, like here. In an arithmetic sequence, the difference between each pair of consecutive terms is the same. It doesn't always have to be increasing, but in this case it is. This difference is called the common difference. Common because it's what they all share. They're going up by 5 each time, right? Now let's say I wanted to find, this is the first term. Term is like each spot, I suppose. Second term, third term, fourth term. Now let's say I wanted to find the 28th term, 28. So if 4 is over there, 28 is going to be like all the way over here. And I could just say, okay, 25, 30, 35, and that's the 5th, 6th, and 7th terms. But to get to 28, it's going to take us some time, right? There's got to be an easier way to do that, especially if I know there's a pattern and I know my starting point. All I have to do is add 5 times. Starting at 5, I just have to add 5 times. How many times to get to 28? Well, we'll see. That simpler way looks like this equation right here. Oh boy. I'll just, right there. A of n, so in this case I said we wanted to find the 28th. So it's a of 1, which is the first term, 5 plus n is 28, because I wanted to find the 28th one. 28 minus 1 times d. The common difference is positive 5. So I'll say 5 plus, and how many times did I add 5? 27 times to get to the 28th number. So I'll go ahead and say 27 times 5, which is, what is 27 times 5? 135. So I have 5 plus 135, 135 equals 140. So the 28th term is 140, which you could get. But look, if you're starting at 20, it's going to take a lot of counting, right? Much easier to just create this sequence, use this equation to your advantage. Moving on to the next page, write the next 3 terms. Oh boy, this is so simple. Identify the common difference. So 7, okay, add 7. Okay, so you're just adding 7. So it's 29, 36, and lastly 43. Okay. Then all these are just increasing. Oh boy, that's so simple. Plus 9. Oh, well, I ignored this one. This is subtracting by 6. So 2 minus 6 is negative 4. Negative 4 minus 6 is negative 10. Negative 10 minus 6 is negative 16. But that's really simple. You just have to identify the common difference and then just go from there. Should not be complicated. This is the simple part of the lesson. Graph the arithmetic sequence. So if you look at it earlier, we started off each of our things, each of our sequences when n equals 1. So that applies here as well. So we have 1, 1, and that corresponds to our x coordinate. So what will I do here? I'll say x is 1, 2, 3, 4. If this is x, what are these? What are those? These are your y's. So x is just 1, 2, 3, 4. These are your y's. So the ordered pairs would be something like 1, 9, 2, 6, 3, 3, 4, 0. This class is not to teach you how to graph, so I'm not going to make those scatter plots for you, but you can figure it out. Again, you just start off at x equals 1, so you have 1, 2, 3, 4, and then these are your y values. Moving on. Determine whether the graph represents an arithmetic sequence. Explain. So you have to have a common difference in the y values, right? It's either going up by the same thing or it's going down by the same thing. So if we look at this, we go up by 1 from 0 to 1, and then from 1 to 4, it's up by 3. Well, up 1, up 3, are those the same numbers? No. Also, if you look at this, does it form a line or a straight line rather? No, it does not. Does this one? Yes, it does. And in fact, this is from number, this is nearly identical to the one we did in number, at the very beginning of the lesson, the Explore. It was 110, 220, 330. This is just a 10 bump in that. But anyways, let's see here. Determine whether, yes. So yes, because the y values are consistently increasing by 10. How about here? It's going down by 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes, the y values are consistently decreasing by 3. This one obviously is no. Y values are not changing consistently. Write an equation for the nth term of the arithmetic sequence. So again, this is what I did earlier in the note section. You say a of n equals the first number plus n minus 1 times the common difference. So let's see here. We are continuing to get more negative by 1.2. So negative 1.2. Here, a of 1 is 43, so you'll say a of n equals 43. And what's happening? We're going minus 5. We're going minus 5 each time, minus 5. So 43 is the first number, a of 1. And in fact, I'll rewrite it. A of n equals a of 1 plus n minus 1 times the common difference. So we have n minus 1 times the common difference is negative 5. So and then for all these are all going to be exactly the same way. It says find a of 10, so I'll just do that for number 17. You guys will practice finding it for all of them. 43, so essentially this is saying, oh, get to the 10th one. So I have to subtract, from 43, I have to subtract 5 10 times, so let's see about that. So 10 minus 1 is 9. 9 times negative 5 is negative 45. So I have a of 10 equals 43 plus negative 45, and that is negative 2. For this one, negative 5.4. I don't have a handy calculator on me. Well, I'll do it anyways. 10 minus 1 is 9 times negative 1.2. Let's see, 9 times negative 1.2. Thanks, Google. Negative 10.8. So I have a of 10 equals negative 5.4 plus all this stuff, and I get negative 16.2. Calculator's best friend. Make sure you use it. Negative 16.2, which is expected. It just gets more negative. Here, that's also expected. You just keep subtracting by 5. All right. Wow. Is that the last? Is that the last of this section? It sure is. So we've closed out the chapter. Oh, oops. In an auditorium, the first row of seats has 30 seats. So the first term is 30. Each row behind the first row has 4 more seats. So the common difference is 4. So 34, 38. So this is 1, 2, 3. How many seats are in the 25th row? So first of all, you'll find A of n is equal to 30, because that's the first one, plus n minus 1. And the common difference is you're adding 4. So times 4. You plug in, you replace n with 25, and you figure it out just like you figured out these ones, except you substituted 10. Otherwise, this is exactly the same. 25 minus 1 is 24. 24 times 4, and then you add that to 30. And that'll be it. All right, guys. So that is the end of Chapter 4. Hopefully you have a finer understanding of, after this section, arithmetic sequences, function lines, how to write them, parallel, perpendicular, all those things. If you have any questions, make sure you ask your teacher. Otherwise, you can let me know. Otherwise, good luck on your chapter test.